Oh, my bad, I was muted. So today we're doing a bit of review, and then we're gonna do Hangman because it's our last session, and having a big project would be nice. So, as we've talked about in day one, variables, you can use them to store anything that you want, usually strings, integers, floats, booleans, lists, or any instance of a class. So some examples, you just like store the word hello, which is a string, into the variable called word, and all that stuff. Yeah, so variables, they're like the basic thing that we have in all of our code every single time, and they're super useful. So we also have conditionals. So you can run code if something is true or false. These are if statements, elif statements, and else statements. And to create them, you have your if and then your condition. So in this case, we're checking if the guess is not equal to the letter. And if it's not equal, then we subtract the life because they got it wrong. And then otherwise, so if they got it right, or if the guess is equal to the letter, then they will reveal the letter. And this is just an example for like if we wanted to do something else. So you notice how there's two equal signs to compare two things. And here there's an exclamation mark equal sign to see if it's not equal. And then there's also other comparators. You can compare numbers. You can compare strings. You can compare lists. So an example, let's say we had a list called words. And let's say like hello. And cool. Yeah. So we can also we can check if words is equal to some other list that I haven't made yet. And that would also check if the whole list was exactly the same. So in this case, it would check if the second list had hello as their first element and cool as their second element, and there was nothing else after that. Does anyone have any questions on conditionals? Not really. Okay. So we also have for loops, which can loop through either a list or they can loop through a code for a certain amount of times that you want it to loop through. So in this case, we're having for, var, and list, and then we're printing out var. So let's try that. For, var, and words, because that's our list. And then we want to print out var. So what this would do is it prints out hello and cool, because when you start off the loop, var becomes the first thing inside the list, and it'll do whatever code that's inside the for loop, with the var being hello. And then after that, it'll go back to the beginning, set var to the second item in the list, and then do whatever's inside the loop again, but with this time var being cool instead of hello. And the other option that you can use for loops is you can make it run inside a range. So for var in range, low to high, and then you print out var, or you do whatever you want inside the for loop. So for loops, not like that. That's a bit more tricky because the range function is inclusive for the first number and exclusive on the second number. So you can say like 1 to 5. And this would make it, this would print out numbers all the way up to 4 because it doesn't actually go up to 5. It goes up to 1, less than that. So that's a tricky part for loops like this that you should watch out for. There's also while loops, which loop until something becomes false. They're similar to conditionals. So we can say while you still have lives, or in this case, while lives is greater than 0, then you can run the game. And then since this loop is going to keep running until they lose all your lives, you can write end game at the outside of the loop, because that is when they will have 0 lives left. And this is helpful for the project that we're going to be making soon. Okay, so functions. Functions are ways to make a code neater and easier to edit. They can take parameters and return values. So as shown inside this diagram, you can have like an input and the function will do something to it and give you an output. And of course, input's completely optional depending on what you want to do in the function, and the output sometimes you don't need either. So let's look at this code. Def get guess. So when you create a function, you need the keyword define, and then the name of the function, and then parentheses. Now inside the parentheses, you can have the parameters. So let's say, let's say I wanted to do like def get age, and then get like name or something. So in this case, name is the parameter, or it's like the input to the function. And then we can do something inside the function based on the parameter that we're given. And you can think of parameters as like variables that exist only within the function. So when we call this function, we can say like get age, and then we give it like Tom, let's say. And now name becomes Tom because that's our input inside the parentheses. And yeah. So we also have this return statement, which you can do stuff with the outside of the function. That's the output of the function. So let's return 12, just because. And so you can do stuff with the output of the function. You can store it in a variable, and then you can print it out. You can do like stuff like that, and it'll set var to whatever you're outputting from the function, and then we're printing it out plus 3. So 12 plus 3 becomes 15. Sometimes, as I said before, you don't have anything inside the parentheses because you're doing the same thing every single time. Sometimes you want to do something to like a value or a string or a number, and you want to pass in a parameter. So yeah, and when you call the function, you just type in the name of the function and then the parentheses. Does anyone have any questions, or is that fine? Does anyone want me to like slow down a bit? Okay, I'm gonna assume that we're fine for now. So for the last bit of review, we have classes, which we learned on day 7 and day 8. And classes are basically a template that can be created and used in your code. And you can create methods inside the classes to do stuff with the classes variables. So in this case, we're creating a game class and we're passing in a word when we want to create it. And then we're also setting the default value of lives to 6. So this def init is a constructor. It's optional based on what you want to do with the class, but it's like a special method inside the class. And then there's also the self keyword, which is something that, like, when you're referring to the class itself or the object itself. So in this case, we're referring to the game itself. And so like the game has 6 lives left in this, yeah. It's kind of confusing to explain, but yeah. And then inside we have methods inside the class. So in this method, it's really similar to functions, but in this case, we're changing the amount of lives left in the game. So we have the self keyword, even though that's not an actual parameter. So you don't want to pass in a value with the self keyword as a parameter. And then usually we have the methods editing something inside the class. So in this case, we're editing the amount of lives left in the class. So we're saying, oh, do they still have lives left? If they don't, then we're going to reset their lives to 6. And otherwise, then we're going to set it to 10 because they didn't die yet. So yeah, that's like a class, but we haven't actually done anything with the class. So we have to create an instance of the class. So in this case, we're saying like main game is an instance of a game with the word hello. This is not really a clear example, but let's say we wanted to create like a dog class, right? This is like the first example that we did. And the dog has a name. The dog also has a breed and whatever. Font is very small. Is there a way to change the font? Whatever.
It's at font size normal in that settings menu.
Yeah. Is it? Oh, large. There we go. Make it huge. Okay, so as you can see, we created a class dog. And so dogs usually have names and a breed and like, you can say self dot owner if you want. And oh, right. So like the dog can have names, breeds, and owners. And then once you create a dog, you just like my dog equals dog, and then that dog will have no name, no breed, and no owner until you set it to what you want it to be. And by accessing the values by doing my dog dot name, you can change the values and do stuff from there. So like jump. And then we're gonna also talk about casting. So casting we're gonna need in this project, and that's basically just changing from one variable type to another. Most of the time we're changing a string into some other thing, or we're changing some other type of variable into a string. So these are some examples. Yeah, we didn't really touch up on that much on the casting, but you can change integers to you can change a string into an integer if the string is like 12, let's say, and int of 12 becomes 12. And then you can also do vice versa. You can change a string into a list. And then you can also change a string into a Boolean, which only happens if the string is exactly true or false. So I kind of went over that pretty quickly. So we're gonna have a Kahoot because these are important concepts that you all need to be familiar with in order to create the Hangman game. So someone asked, will you go over how to make the game step by step? I plan on giving you guys time to try to create the game as much as you can before, but I will, at the end, I will create the game step by step. So we're gonna wait until we have like at least 10 people, because I'm pretty sure there's more than 10 people here. Okay, so I'm gonna give like 1 more minute and then we're gonna start. So hopefully people can join. Okay, well, if you still haven't joined, you can still join while we're playing. But I'm gonna start now. Okay, so some people got this wrong. So I'm gonna walk through the logic. So this is a classic conditionals problem where it's either true or false at the end. So it's not gonna be no. So the first thing that we're gonna check is the stuff inside the parentheses. So we're gonna check if 3 is greater than 5, and since 3 is not greater than 5, which I hope you all know from math class, then this becomes false, and then not false becomes true. Yeah, and then afterwards we look at this other part inside the parentheses. So 5 is greater than 3, which is true, so it becomes not false and true, and so not false becomes true, and then it's true and a true, which is true because both sides becomes true. Okay, so most people got this right. I'm just gonna go over it pretty quickly. So we have this list called letters, and it has hey, right? And then dot append adds the value inside the parentheses to the very end of the list. So it becomes hey and then the O at the end, which is what people got. It doesn't add it to the beginning, so it only adds it to the very end. So this is a very confusing question that most people got wrong. So, oh, there's no media. So the fourth element in the list is not the same as the fourth index in the list. So lists start, okay, I'm gonna create a list. My list equals 3, 2, 5, and 8. Let's do that, right? So you can see that there's 4 elements in this list, or like 4 different values in this list. But lists start at index 0. So if I printed out the 0th index, it would print out the first element, which is 3. However, so if you wanted to access the 4th element, it would be the 3rd index. So this is a thing that's probably going to trip up a lot of people when they're coding. But yeah, if people were confused about why I said element rather than index, that's my bad. And whatever list and then dot 4, that's not a thing. So you can't do that. So to access elements inside the list, use the square brackets and then whichever index you want, which is going to be 1 less than whatever element you want. If that makes sense. Okay, so we touched up on this a bit during the review. So functions, they organize your code. They can have a return statement. They can have parameters, but they don't need to have parameters or a return statement. So let's make an example. Define, what do we want to do? Add 3. So in this case, we're going to have a parameter, let's say number. But let's say, oh, we don't really want to save that value, right? We just want to print it out. Num plus 3. And this would run perfectly fine. 12, 10. Let's do 10. So in this case, it would print out 10 plus 3, but there's no return statement. However, the only reason why you would need a return statement in a function is when you want to do something with the value at the end. So this would still print out 13, but now we can also store 13 into another variable, new number. And then we can do stuff with the output afterwards. Okay, everyone got this right. So I'm just going to run through this very fast since everyone got this right. So this is false because 5 is not greater than 15. And then not false becomes true. 6 is greater than 5, so that's true. 0 is greater than -1, which is true. And then it's true and true and true. So everything's true. Okay, so like half of you guys got this right. So, okay, let's look at this. So there's a function called math, and it takes in a number. So in this case, the number is going to be 5, right? So, and then we have a while loop inside that's running while the number is greater than 1. And while it's greater than 1, then we want to subtract 1 from itself. So what this would do is, okay, I'm gonna try typing this up really fast. Def math num while num is greater than 1, num equals num minus 1. I'm also going to print out num over here so that becomes clear. And then we want to return num at the end. So this is basically what the question was asking, right? So when we do this, num is going to be 5 at the beginning. And since 5 is greater than 1, it'll run this code inside. And it'll be like, it'll set the new value of num to be the old value minus 1. So in this case, the old value is 5, and 5 minus 1 is 4. And that becomes the new value of num. And then 4 is greater than 1, and then this whole thing repeats until num is not greater than 1. So let's try it out. So as you can see, num becomes 4 after the first time it runs, and it becomes 3, then it becomes 2, and then it becomes 1. And then 1 is not greater than 1, so it'll return 1. Hopefully that made sense. Okay, so most of you guys got this right. That's good. So in Python, you use the word in to check if a value is inside a list. These other ones, yeah, they don't really work in Python. I'm not really sure if they work in any other languages also, but probably depends on the language. But yeah, in Python, you want to say whatever item you want or whatever value you want to check for inside the list, and this will be true or false. Let's try it out in REPL. So I do. So we have this list, right? Then we want to print out, let's say, 3 in my list. I don't know why it's still, okay, there we go. And what this would do, it'll look inside my list and it'll check if 3 is one of the items inside the list. And in this case, it's true because it's the first element inside the list. But if you try the other ones, I don't think it would work. Oh, okay. So yeah, as I went over inside the review, I touched on it kind of briefly, didn't really explain it that well. But when you're looping through a range of numbers, the first number is always going to be inclusive, and then the last number is going to be exclusive. So in this case, it will, okay, let's try coding it up really fast. So what this would do is it would start off I to be 1. So I is just a temporary variable inside the for loop, and it'll start off at the lowest number in the range, which is 1. And then it'll print it out, we'll go back, go to the next number inside the range, which is 2, and then so on and so forth. But it'll never go to the last number. So as you can see, if you can see that, it goes from 1 to 4, and then it stops. So it only runs 4 times. Usually, if you only have one number inside the range, then it'll start off at 0. Well, so in this case, yeah, it'll run 5 times, but that wasn't what the question was asking. Oh, this is tricky. So functions end at a return statement. So everything inside the function that's after a return statement will never run, even if you call the function. So I don't know if I want to show this right now. But yeah, it wouldn't print out an error. It would just not print out anything, because it wouldn't even look at this code and be like, oh, that's not supposed to happen. It would just pretend like it never existed. It would just print out nothing. So yeah, it's not going to print out 6, and it's not going to give an error. It's just going to do nothing. My word is a list at the end. So in this case, we have this variable called my word, right? And it stores a string. And then we cast it into a list. But the problem is we're not storing the value of the list. So casting will not change the value of whatever is changing until you set it to like another variable. So let's see. What was it? My word equals pineapple, and then list. Let's print out the list of my word, and then let's print out my word. So as you can see, it'll change each thing, each letter inside my word to be an index inside the list. But my word is still pineapple. It is not the list itself. So if you didn't have this print statement, you would just be casting it, and you wouldn't be doing anything with it. So it would basically be like a useless line of code that never actually did anything, unfortunately. Okay, cool. So that was the Kahoot. We're gonna go over a bit of uh, practice for classes because I think it's a key concept that you have to grasp pretty well in order to make the game. So I want you guys to create this class, this person's class with attributes like a name, hobbies, and friends. And then you want to create methods that let you add and remove hobbies and friends. And you also want to create a greet method that prints out a greeting for the person um, and checks if they are already a friend. And if they aren't, make them a friend because that's what socializing does. Um, so I'll give you guys probably 5 to 10 minutes on this. And if you get to the challenge, type it in chat. And if you also need help, you can message any one of us or me directly if that works. Okay, so I'm gonna go over um, this practice right now. Can I get like a general idea of like where you guys are? So did you guys finish, you guys got to the challenge yet? Or did you guys get to the GREAT method? Or are you working on the GREAT method? Just like say it in chat so that way I can see if like where people need help. Okay, so pretty sure most people are almost done with the GREAT method. So I will give it 1 more minute and then I will go over it. Okay, hopefully people finished up at least with most of the class, if not the whole thing. I'm gonna go over it. And so if you're stuck with any of the, if you're stuck with any of the parts inside the class, hopefully when I go over it, it'll make sense. So it's asking for a person class with the attributes like names, hobbies, and friends. So I'm going to create a class called person. And have a name. I'm going to have hobbies. And I'm going to make this a blank list. I'm also going to make the friends a blank list. Because when you create a person or a person at the beginning doesn't really have any hobbies or friends, just kind of sad. And then we want to create methods that allow people to add or remove hobbies and friends. So, oh, my bad. I paused the screen share. So, yeah, I started off with a class called person, and it has a name that's empty, no hobbies, and no friends, which kind of sucks. Anyways, so we wanna create a method that lets you add connection issues, please. Okay, so we wanna create a method that lets you add. Okay, I need to reload this. Sorry. I think REPL is just a bit slow in general sometimes. Cool. define a method. Let's call it add friends, or add friend, because we're going to add one at a time. And then what we want to do is self dot friends, and then we want to add something to the list, right? So we want to append it, because that is the way to add something to a list. And in this case, we're going to have to ask for, oh, what friend do you want to add? Or what person do you want to add as a friend? So we're going to have a person. Then we're going to add this person as a friend. And so now whenever you call this, we give it a person, and then it'll add it to the person's friends list. We could do the same thing with del friend. That's kind of awkward. Remove friend. There we go. Self and person. And every single time we're creating one of these methods, we have the self keyword as one of the parameters, even though it's not a parameter. So that way it can access their own like friends list, their own hobbies list, and stuff like that. So self dot friends dot remove. So what remove does is it removes a specific value from the list that you're doing stuff on. And in this case, we're removing the person from the list, which is kind of sad. We can do the same thing with hobbies. I'm just going to copy paste it because it's about the same. We just have to change it from people to hobbies. This is usually you'd want to type out all of it so that you know what you're actually doing. Because so yeah, this is bad code practice. Don't copy paste. Yeah, don't copy paste stuff. Usually. Now, what else do we have to do? We have to create a greet method that takes in another person. We greet them, and then we add them as a friend if they're not already a friend. So let's create this def greet. So this is going to be similar to the add friend thing. We want to print out hello. And then since this person has a name, we can get person.name, or at least the person should have a name. And then we can say like, hello person, how are you today? Pretty simple greeting. And then we want to check if they're already one of your friends. So check if person is in friend, well, self.friends. And then, so if the person's inside the list, well, we don't really need to add them to the list, right? So a person is, if not person in self.friends. This is a bit confusing, but basically what I'm doing is I'm checking if the person's in it, and I'm saying, well, what if they're not inside of it? I don't think saying not in, I think it works either way. So if person is not inside the list, then we can add them to the list. So we do self.friends.append person. And there we have it. We've greeted them, and then we checked if they're inside the person's friend list. And if they're not, we add them. Now a challenge, we have a best friends list. So best friends. Now the person has a list for friends and a list for best friends, which hopefully they're not mutually exclusive. And then we want to create a method that adds any friend to the best friends list if they have at least one similar hobby. So this is going to be a bit different than what we've done before. I'm just going to name this like best, add bestie. Why not? So what this would do, it doesn't ask for like if a person is specific, if a specific person's inside, or if a specific person has at least one similar hobby. It asks if any of the friends have at least one specific hobby. So we don't need this person parameter.
네. Sure. 네.
So what we do need is to check each person. So we're going to use a for loop for that. For I in self dot friends. So what this would do is it goes inside the friends list, and it makes I each one of them every single time it loops through. And then what we want to do is check if the friend has any hobbies, right, that are the exact same. So in this case, we're checking a list to a list, which is kind of hard. So I'm going to make another for loop inside of it. Now what this does is it allows us to compare one hobby at a time. And then we can say if I'm going to rename these because if friend self.friend, so if friend dot if J is in friend dot hobbies. So what this does is it checks if the hobby that we're checking right now is inside the friends hobbies list. And if it is, then we add the friend. So self.best friends dot append friend. So now they're best friend. The reason why we need 2 for loops is, let's say you had more than one hobby, right? If you had more than one hobby, you can't check a list of hobbies and compare it to a list of hobbies that simply with like an in statement. I'm sure there's another way of doing it with like any statement, but that's a bit more complicated. So we're gonna check if we're gonna compare each hobby to another hobby and see if they're the same. And if they are, then we add them to the friends list. Oh. And if this doesn't happen, well, they're never gonna be added. However, we want to make sure that we don't add them multiple times. So a thing that we can, I'm not sure if we talked about this, but we can, oh yeah, we can just return. We can return false or whatever. And that'll automatically end this function. Oh wait, that's not what we want to do though. We want to break out. Okay, so I'm going to go through this function again because it's a bit confusing. So we have this for loop that goes through each friend inside the person's friend list. And then for each friend, we get one of our hobbies, and then we compare it to each of the hobbies inside the friend's hobbies list. And then that way, if one of them is the same, we add it, and then we break out of this statement, which then moves on to the next friend, and so on and so forth. So nested for loops or nested loops in general are pretty handy sometimes. So yeah, let's try testing this out. So let's create a person, Joe equals person, then Joe.name equals Joe dot Joe dot add friend. Oh, but we don't have a friend to add, so let's make another person. Let's make it Bob. There's another person, and Bob dot name equals Bob. Let's give Bob some hobbies. And let's say we add skating. Let's also give Joe a hobby. And then we add Bob as a friend. And then let's print out Joe dot friends. Oh. Joe dot, wait. I see the problem. Okay, so let's print out Joe dot friends. Let's print out his first friend's name. I think that should print out Bob. Yeah. So yeah, this person class, I think it works fine. We can test the other ones, but I want to move on to the project because that's a lot more exciting. So yeah, let's do that. So Hangman, I'm sure a lot of you, if not all of you, are familiar with this game. So in this case, we're going to make it a 2-player Hangman game. So the first person is just going to give the computer the word, that you want the second player to guess. And then afterwards, the second player will guess one letter at a time. And you're gonna start off with 6 lives because there's the head, the body, 2 arms, and 2 legs. So that's 6 things that you need to hang a man, which is kind of graphic. Anyways, and this is completely optional. You can check if the player guessed the same letter over and over again and stuff like that. And then at the end, you want to say if they won or if they lost. So let's do something like this. Hopefully you guys can see this. So it's gonna say, give me a word. Let's see. I'm gonna say, does anyone have any word suggestions? Apple. Okay, let's just do apple. That's a basic word. So as you can see, it'll print out how many words you have so far. And then it'll also print out the guesses that you've made before. But in this case, we haven't guessed anything yet. And then it's gonna say, guess a letter. So I'm gonna guess E, because that's the most common letter. And wow, it replaced the last underline with E because that's the last letter in apple. And it'll keep running until you get the word right. But let's say you got it wrong. So now there's a head, and now you're 1 life down. Yeah, that kind of sucks. So I'm just gonna, so if you guess it right, and there's multiple letters inside the word, you want to replace all of them and show them to the person. So I'm just gonna finish this game. As you can see, it says you guessed the word correctly. The word was apple. So I won. So that's one case of what could happen in the game. Now another thing that can happen, let's do apple again, is if you got everything wrong, well, you just hung the man. You killed him. And you didn't get the word apple because you ran out of lives. Yeah, so this graphics thing is completely optional. Don't add it in at the beginning. Focus on just creating the game. But it's pretty fun once you finish the project because you can play with like your siblings or your friends or your parents or whatever. I don't know. But yeah, the main points in the game is you give a word and then it'll show the word that's been revealed so far. And it keeps track of the lives and it asks for like guesses every single time. So it covers basically all the stuff that we went over before. And these are like more specific steps. I'm not gonna read it off, but hopefully they redirect your attention so that you can focus on one thing at a time. And some of this is like completely optional. So this stuff is optional as long as you get the word working, or if you get the game working, you're all set. So here are some methods. Again, you can cast a string into a list and it will make each index of the list one character of the string. So this is handy for creating the the unrevealed word and like revealing specific parts. You can also get the length of a string or list by doing len and then whatever you want. You're gonna have to use at least one for loop and at least one while loop because you want to run the game while they still have lives left, but they didn't get the word correct. And then you're gonna have to probably add values to a list, which is super helpful for like listing which letters they've already guessed. And then you also can combine the elements of a list into a string. So this part, it just makes it look nice. It's completely optional. You can just print out the list itself. But yeah. So again, you can have two players. One person inputs the word, and then the second person guesses until they get the word correct, or if they lose all their lives. And even though this is doable without classes, make a game class. So as you can see in like the limited amount of code that you can see from here, I created a word class, and then I did all the logic like outside of the class, but everything's inside, like all the methods and functions and print statements are inside the class as methods. So yeah, that's the project. So
Let us know if you need help along the way because it's kind of a difficult project. So
yeah, it's really open-ended, even though the goal is the same for everyone. But yeah, for starters, I suggest you just start off by creating a class and think of what each game of Hangman has, or what I keep track of over here every single turn, and make those the class variables, and then move on from there. Oh, someone asked what's the hashtag stuff for? Oh, these are just commented out stuff. I made two versions of this game. One that has like the fancy print stuff and checks if like all the guesses and words are valid. But yeah. So you have like basically the rest of this time to go work on it. Oh yeah, also I highly suggest you let counselors look at your code so that whenever you're stuck, we can just help you immediately. So just like give the link to your code to like one of us, and then we can go look at it. So when you're coding this, don't focus on the big picture too much. Just focus on one thing at a time, and then you can combine everything at the end. That really helps me and usually a lot of other people just like stay focused and not get overwhelmed by like the whole project. Okay, so I'm gonna give you guys about 20 minutes, and since that's like when the class ends, but if you want to stay for the solution, or if you're stuck on some things and still want some of our help, um, we can stay overtime and give a step-by-step instruction. So I'm gonna show the example again. So if you're kind of stuck on like what it looks like, or if you're forgetting a bit, then yeah. So let's look at this. So it asks for a word. I'm gonna give it a word. Let's make it apple again, because why not? And then, so after we get the word, it's gonna save the word, right? And then it's also gonna save another list that will keep track of the blank spaces in the word, or the word like without any guesses. It'll also keep track of guesses and the amount of lives from here. And then after you have all of those variables, then you want to get guesses and either change the amount of lives or change the revealed string from there. Hopefully that helped if anyone needed help. Also, if you want me to like move to a different slide on this presentation, I'd be happy to. Okay, so hopefully you guys are almost done or getting close to finishing. So I'm gonna start explaining a step-by-step on how to create Hangman. So let's create a new one. New Hangman. Oh, here we go. So first off, let's look at the presentation. So we're gonna have a loop while this game is still going, yada, yada, yada. So as I said, we're gonna start off by creating a class. I'm gonna name this class game. Now I'm gonna name it Hangman. And Hangman has, so each game of Hangman has some specific components, right? It has the word, has the amount of lives, it saves like how much the word has been guessed for. It saves all the guesses that the player has made if you want. So yeah, let's do that. So we're gonna have lives equal 6. We're gonna have word equals nothing for now. We're gonna have the revealed, and I'm gonna make that an empty list. You might see later why I do that. Gonna have guesses. I'm also gonna make that an empty list. And that's the class so far. So at the beginning, we have to ask for a word, right? Oh, so let's create a function for that, or a method for that. So def set word, and I'm gonna give it a self because it's gonna change the game itself. So what I'm gonna do in here is I'm gonna ask for the word, right? So I'm gonna do input. I'm gonna be like, give me a word. Give me a hard to guess word. There we go. And then what I'm gonna do with that input is I'm gonna set word self.word to be the input. So now the game itself has a word that the player input. Let's see if I can make this nicer to read. There we go. Okay, so we have the input. I'm gonna make this all lowercase because that way it is like uppercase letters won't be counted as like completely different guesses, but this is completely optional also. You can just like tell them don't put any uppercase letters or whatever, and it'll be the same thing. So so we have that part done. Now player 2 will guess while the game is still going. So let's create a method for every guess. I'm gonna name this get guess or set guess. Should we set guess? Whatever. Set guess. And this is also gonna change something inside the game. Okay, so in here we want to ask for the person to give a guess. So I'm gonna say guess equals input, give me a guess, lower because I can, and then I'm just gonna add that to guesses. So self.gases.append gas. Yeah. And for each gas, we have to check if it's inside the word. So what I'm gonna do to make this a bit nicer to work with, I'm gonna make a word list. And it's just gonna be the same as the word, but it'll be in a list format. So self.word list equals list of word of self.word. There we go. Also, I'm gonna initialize revealed over here. So what revealed is gonna be is, let's look at the example again. Revealed is gonna be the underlines over here. So it's gonna be just underlines until they guess it right. So self.revealed equals, and I'm just gonna give it an underscore and multiply it by the length of the word. So what this does is it makes this revealed list become however as many underscores as there are letters inside the word. And that way it'll just leave it all empty as if it's like you haven't guessed any of it, which is what we want. So we should also create a method for okay, so we should also need a method for checking if the guess is in the word. So I'm gonna do this, check guess self. And what I can do is say, oh, if I can check if guess is, I can check if the guess is inside the word list. But what I want to do is go through it and reveal the guesses if they're right. So I'm going to make a for loop for I in range of word list dot. I'm going to make it length of the word list. So what this will do is it'll loop through, it'll loop however many times there are letters in the word. And this is nice to have because what I can do is I can, what is it? I can check each guess to the word or the letter in the position. So if self.guesses of -1. So this is handy because we just appended it, and then we want to check it. I'm like all over the place right now, but this will hopefully make sense at the end. So if self.guess is -1, which is the last index or the guess that we just appended, is equal to self.word list of the same of this I index, which will check each letter inside the word. And if they are the same, then we want to reveal the letter inside the revealed list. So self.revealed I equals to self.guess self.word list of I also. Oh, I'm gonna make this self.word list also. So we have it being checked, and what we also want to check is if they even got a guess correct. So I'm gonna create a variable that's called like correct, and I'm gonna set it to false because If they don't get it right, this thing is going to stay false. But if they do get it right, then we can make it true. And setting it true multiple times won't change anything. It's still going to be true. So if there's more than one letter that's inside the word that's equal to the guess, it'll still be true. And then from there, we can check if they got it true at the end. So if, or if they got it correct at the end. So if correct equals true, then what you want to do is not subtract the life. But if correct is not equal to true, then what you want to do is subtract the life. So self.lives equals self.lives minus 1. And this is just subtracts it from itself. And that's most of the game. Now, what else do we need? I'm going to skip the optional part because we're short on time. And now we have to end the game and check if they're either out of lives or if they guessed it. So I think we're mostly done actually. So I'm going to create an actual instance of the Hangman game. So game equals Hangman. Now what this does is, so this whole thing was just like a template for what we wanted to do. And now we can actually do stuff. We can actually like create an instance of the game. So we can do like game dot set word. And then while, so we want to run the game while they still have lives and they don't get the word correct. So while game dot lives is greater than 0, or wait, and game dot, what is it? Game dot word list equals to game dot revealed. So what I'm doing here is, since word list and revealed are both lists, and we gradually reveal each letter until the word is the same, I can just compare the two because we're comparing list to lists. And if they're equal, then they guess the whole word. So for each turn, we want to set the guess, which will automatically check the guess. And we forgot one thing, which is actually showing everything that's happening. So def display. And this is just going to be like print statements of like, let's see, you have blank lives left. You can also say like print word so far, and then print out the revealed list, which is basically how much of the word is revealed, which is what we want. And then we can also print out your previous guesses. Oh, we forgot one thing. Oh, no, we didn't actually. So self dot guesses. And what this will do is it'll print out how many lives, the revealed word so far, and how many guesses you've done. So again, game dot display, game dot set guess, and it'll also check the guess since I called it in here. And it'll automatically update the lives and the word, if depending on the guess. So once the game ends, we want to check if they still have lives left. So we have if game.lives is equal to 0. That means that they lost, right? So you want to print out you lost. The word was, and this is completely optional. You can just like print out the word by itself. Game.word. There we go. And otherwise, which means they still have lives and they finished the game, which means that they won. So you can print out you won. You had blank lives remaining. Okay, so I think we finished most part. So let's try it out. So hard to guess word, apple, and that's a problem. So what happened here? Let's see. Game.lives equals 6. So we want to check if they're not equal to each other. Wait. What? I'm confused a bit, but okay. So you have 6 lives left. Word so far, it's just underscores. Your previous guesses is empty. So let's guess A. And again, it'll reveal the letter. It'll show your previous guesses and stuff like that. Now this doesn't hide the word. So what I'm gonna do is inside set word, I'm just gonna like run a loop that just like prints out nothing, so that it hides the word at the end. So now you can't see the word unless you scroll up, and which is perfectly fine. So now we can just keep guessing. And as you can see, it subtracts the lives, it saves the amount of guesses, it starts revealing the word as you get it right. And if you finish it, it says you won. So hopefully that helped for people who stayed. And yeah. So thank you all for coming. This was the last session. And yeah.
And nice job, everyone.
Thank you, everyone.
Yeah, thanks for sticking along for the last 9 sessions. And we hope you learned a lot and continue to apply this forward. Continue to practice programming for fun. You can do your own research, do your own projects, and it can be a lot of fun. So remember to have fun doing it. All right, see you all. Bye.
Bye.